Okay, so for today we are going to finally configure something in TrueNAS. And as I announced yesterday, last episode, I will think long and hard about how I want to set all of these 20 drives. And I had my fair share of mental breakdowns. It took me a while. I used multiple, let's say like online calculators to figure out what I want and what I don't want or what I require for long-term operation in here. And I think I settled for something. So let's have a look at TrueNAS over here in one of my million tabs. Here, let's just, So here in TrueNAS, I can create a new pool, a new storage pool. And, we first need to give it a good name. Like my old one was just called Hela, and the whole server was called Hela. And I won't go with Hela 2. Okay, give me some nice sounding mythological names. Yeah, Nordic. Sif. Skadi, Hulda, Atla, Eir, Isa, Embla, Saga. Saga was a goddess who was most depicted drinking with Odin. She was the source of the world Saga. Drinking with Odin. That sounds nice. Saga. 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 Yes. Okay, so here we get to the drives. And unlike what your Windows disk creation tool will offer you, in TrueNAS we are talking about ZFS. And I don't want to get deep into ZFS because people who are knowledgeable in that topic, that's like a cult. ZFS, there is a learning curve which is incredible. So I won't even go any deep into that. I don't want to fiddle in there. I will certainly get something wrong. But there is a very base level of understanding with which you are able to work. So in TrueNAS, what you can do is stripe the disk or mirror the disk. Basically a RAID 0 or RAID 1, which is nothing irregular, but I won't do any of them. A stripe I would just never do. I did that as a kid, where I had multiple hard drives and just a stripe across all of them, because I thought reading from them at like 5x speed was fine, it was nice, until one of the drives goes away, then nothing is nice anymore. And mirror is basically a one-to-one copy, so I will lose half of everything, which I can't do. I need more than half. So those two are out of the question. And then we get into RAID Z, which is not an equivalent to the original or to the old RAID that you see under Windows Creation Tool. It's not the same thing, but it works in a understandably similar manner. Like for example, you have RAID Z1, RAID Z2, and RAID Z3, and a RAID Z1 would be more the equivalent of a RAID 5 in like old terms. The thing is, with RAID Z1 you get one disk parity, or one disk as a parity, which means that per Z1 pool you can lose one disk. How ZFS works is you create like blocks of some configuration and then you add more of the same blocks to the same pool. So for example, if I have a RAID Z1 and I choose my 18 terabyte disks, then I can say how wide a Vdev will be of that pool. And let's say I say it's 5 disks wide, so 1 out of 5 disks can die and I can still resilver or recreate the original pool. And from there I can say that I in my case can add 4 of these 5 disk wide Vdevs. So in total we gonna have the 20 drives used, 5 per block, 1 of them can die, and 4 blocks. So in total 4 drives can die because we got 4 blocks and 1 per block can die. I hope that makes sense. And that will give me a total capacity of 291 terabytes. And the leftover, or the missing, 110 terabytes to the 400 that we have in total are used for parity. So that's all the drives that we lose to make sure that if anything goes wrong and one drive dies, that we get all of our data back. Now we could go even one higher, or we could even change this. For example, I could say that every block, so every Vdev is just 4 disks wide and I can add 5 Vdevs. So now we got blocks of 4 disks times 5, still making a total of 20, but we can lose 1 out of 4 drives instead of 1 out of 5. And in this case, we get 272 terabytes. So we lose a bit of data, but we win that we can now lose more drives. So now we can lose a total of 5, whereas before we could lose 4. This will also affect performance to some point. There are millions of different calculators that each of them will say different things, and you got people who generated like whole tables of a million different configurations where you can see the write and the read-write speed, and I'm very thankful for the work of all of these people. But I believe with the amount of drives that we are playing here, it's not that important. I believe there are going to be other factors that are more important than saying five Vdevs or 5 blocks of 4 drives are going to be quicker than 4 blocks of 5 drives. I think the difference between the two will be negligible at best. However, what we could also do is say we want to RAID Z2, which means that we can lose 2 drives per Vdev, or we will use 2 drives as parity in case anything goes wrong. And as you already can see here, it will tank our total capacity in a huge way. Now, even if we say we got 5 drives in a Vdev and we got 4 of them, we are already at 218 terabytes. And if we turn this around and say we got 4 drives and 5 Vdevs, which means that actually we are just using 2 drives per Vdev and everything else is just parity. In that case, we are tanked down to 181 terabytes. So we lost almost half of my half pool just to be sure that nothing dies. Now you could go even higher, of course. You can say a RAID Z3, which means that you can lose 3 drives per pool, and then we can add, in this case, we need to add at least 5 to make it happen, and then 4 Vdevs, and we are down to 145 terabytes. So we lost more than half of my total capacity, which I will most certainly not do. After banging my head against the wall for hours and hours, I believe I know now what I want. And what I want to do is a RAID Z1, so 1 disk parity per Vdev. I want to make the thing 4 drives wide, yeah, and I want 5 Vdevs, which means that per Vdev I can lose 1 drive. So 1 out of 4 drives can die. And actually, if you have a look at the front of my server here, it's basically how the blades are set up. We got 4 disks in a blade, we got 5 blades, making a total of 20 drives, and I can lose 1 drive per blade. As long as not 2 in a single blade will die, everything will be fine. I can always re-silver or recreate the pool and change out the drive, and we are going to be fine. That's, I believe, what I want. Out of 20 drives, I can lose a total of 5, which is 1/4. So, sounds to me like a pretty safe setup. I know. I could change that up. I could mirror and add with RAID Z3 and do all sorts of stuff. But I think this is a good middle ground. This should do it. We got 5 Vdevs, 4 drives per Vdev. We can lose 1 out of 4 drives 5 times. Sounds fine to me. This is like the hardest decision about all of this. Everything we do here, this was the hardest decision. No log, spare. Yeah, we could also add spares, but I won't do that. No, let's don't. Now, the cache is another important part, and I installed that one M.2 SSD, that NVMe SSD for this one specific reason. And I don't know how well this will work, and we will find out very shortly. My idea of how this works, it does give you like a little explanation there. ZFS L2 org read cache that can be used with fast devices to accelerate read operations. Now, how I expect it to work is we have that 1 terabyte NVMe in there. And what I very often do is I record a video, I record B-rolls, I record whatever. I go onto my editing PC. I have like one of those Kingston docking stations. I slap in the 2 SSDs, the 2 SD cards. I copy everything onto a RAID 0, funnily enough, to NVMe wide drive on my PC. I recreate we have like a standardized folder where I have all of my presets, my sound effects, a couple of images that we reuse in every video. I prepare a whole project. I copy all of the A-rolls, copy all of the B-rolls, stats if we have some. I prepare the whole, let's say, project to work on, and I copy all of that onto the server. Now, these projects sometimes can be 200-300 gigabytes big. Now, 300, that was like a very huge project, but like 150 gigs, that's like the usual A-roll, B-roll of like, let's say, a fan. Now, what very, very often happens is my second person in the office copies down that project and she cuts all of the A-rolls. That's like our workflow very often. Or for example, these like server videos, building videos, she does the whole thing. So I prepare everything, slap it onto the server, she copies it immediately down, like a minute after. Now the problem with my old setup is it will always be restrained to the hard drive read speed. And even in this case, even with all of the ZFS RAID Z thing that we have got going on, the limiting factor will still be our hard drive read speed. And I want to get past that. And how I imagine this cache drive will work is ZFS should be caching at least that one project that I am throwing onto the server. And when she copies it down, she won't be affected by the read speed of the drives, but by the read speed of the M.2 SSD, because I imagine it will still be cached on there or in RAM, maybe, if TrueNAS works that way. But that's like my ideal situation, and that's why I have that cache drive, and I hope that it's also like that it works. Now we are going to find this out pretty quickly. Once we got everything set up and I have access to the server in like Windows, in a Windows Samba way, I will copy up a gigantic project and then use another PC to copy it down and just see how quickly it goes. And if I'm right, then if the project is bigger than 1 terabyte, the first terabyte will be really freaking quick, and then after that we'll just tank down to whatever the hard drives allow. That's how I imagine it will function. And I sincerely hope that I'm right, but we will find that out. But for the cache drive, we got the 1 terabyte SSD, one wide, because we can't add more, because I don't have any. But what you could do is add another like PCIe to M.2 NVMe adapters and then just slap a bunch of them in there. That's always a possibility. And also something I forgot to say about the data part of this. Now we got the 5 Vdevs, which are 4 disks wide. What I could do in the future is add like another hard drive chassis where we got just hard drives and connect them somehow to the whole server part and add additional Vdevs, which are also 4 wide, to the pool, making the total capacity bigger and bigger and bigger. And as far as I'm informed, the only restraint that you actually got is that you need the 4 drives. Every time you do that, you need like a full VDEV of 4 drives, and you can slap more and more and more and more in there. But that's like a future problem. We still need to somehow fill 272 terabytes of data, so I think I'm going to be fine for a long time here. No spare cache drive, and I believe the same for the cache drive. I should be able to just add more cache drives at like a later point. If I see, for example, that my copying up and down works perfectly fine, but I need more of that quick copy and pasting down, then maybe I will need more cache drives. But for now, 1 terabyte should be fine. Metadata, special allocated class, used to create fusion pools, optional VDEV type, which is speed up metadata and bulk. Yeah, no. Nope. Okay, we got to the summary of our topology. We got 1 cache drive, 4 terabyte. We got 5 Z1s, each 4 disks wide of 18.19 terabytes of actually usable like data storage capacity, which gives us a total of 272 terabytes and a total of 5 potential disk failures before we get into a dark zone. Let's create the pool. Oh yeah, the drives are working now. I can hear them like spin up. Whew. Yay, the ZFS is healthy. Whoa, no disk died yet. And apparently I can see also all the disks. Yeah, I can see all of them, that they are healthy. We got smart enabled. Great. Whew. Okay, now we got the whole thing running, and we still need to make it accessible over Windows. And how TrueNAS is doing it, or basically every server that you want to use that way. But we're using Windows SMB or Samba, and back in the day, or on my old server, we still had the option to choose like the Apple equivalent of that, but apparently they have faded that out, which doesn't really matter because macOS has been using SMB for quite a few years now. So what we need is a whole set of things. First off, a Windows SMB share, which we can just add, and we can use the very basic path of the whole ZFS cluster, which I need to specify a bit, but this will create our sharing point, where we will get into the whole thing. And now from there, we also need users. Apparently, logging in as root is not allowed anymore, so I'm going to create myself a new user, which which if I can write my own name, like that, give myself a password. And what I'm not going to do is, it will also create a group for myself. What I'm not going to do is create any sort of home directory, because they will try to do that automatically, where they just create a Christian folder, and that's where I would put all of my personal stuff, which you would do in a company where you get multiple workers and you want to share, or you want to save all of their like personal files somewhere in like a home directory, which I'm not going to do, and then just save the whole thing. Now from there, we need to do one last thing, which is a data set. And that's like a dark pool, which I'm not very knowledgeable in. But what we can do is add a new data set, which in this case I will just call STS, and it will inherit for now everything. And from there, we now got let's say a folder which will be called STS, and I can do the ACL thing here, the permission of that directory. Permissions. Why isn't it called ACL anymore? Anyway, I can here add permissions to the whole thing, and I will choose myself, and I will also choose my whole group. And I don't need to do this because the server is empty yet, but I can also do this recursively. So going down into every folder which is down or a level beneath the folder that I have currently chosen. So if I would have like you can see in the top the mounting point for Sega, and then the folder STS, and then I don't know, STS old videos 2023 January, and so on. I could add permissions recursively down to the last folder instead of just like the top one. But in this case, everything is empty. And I will just give myself the whole schmuck here, read, write, execute for the whole thing. Oh, and here I can do ACL. Yeah, but I will do it now like this. And I need to do the whole thing again. Yes. Recursively. Yes. And I will add myself the whole permissions tab. So now we got Sega as, let's say, the pool, and we got STS as, let's say, a folder, and the whole thing is connected. The data set is shared via SMB. And I exist as a user with my personal name and a password, and I can log in and I have read, write, execute rights in STS as a whole. Which means that by now I should be able to map a network drive. I can already scan it, and you can see here Sega as like the server, and then STS as a folder, let's say. And I can log in, and ta-da! And we got the whole drive here, 264 terabytes, which is 7 terabytes less than it said I would have. Interesting. But if I'm not mistaken, I should now have read, write, execute rights here, which means that I can copy over this 1.5 gigabyte file, which gives us 92 megs per second, which is not a whole lot. I know that. But we got the 264 terabytes. I have access to it. I have some level of user control. And theoretically, the server is running. Now, I had only 100 megs up, which makes absolute sense. It's not restricted by the drives, but by the fact that I'm running from a mini PC here to I think it's a regular switch, which cost me like 5 euros. So there you have the bottleneck. That's why we are only running on 100 megs. But you know what? Can I connect the server now quick and dirty? Should I do that now? Yes. Should I do that? Should I now, or will the video be too long? Okay, no. For today, the server is running way too slow, I know that, but that's going to be for the next part, because we got a 10 gigabyte switch in the office where we got that fiber connection, or never used, but we got a potential fiber connection, and we got the SFP. I still have to figure out how these cards work. The network card using the same fiber connection here in the server. So for the next episode, I will connect that one instead of running through that bottlenecking switch over there. And we will try this again, copy a file up, and see how quickly that goes this time. But for that, I need to connect the server to the switch and connect this PC to the switch, not using this PC to the 10 gig switch, but not using the 5 euro switch that is just lying here. And we're going to do another thing, because I bought a UPS, or a uninterruptible power supply for the server, because we had power outages here, and what I don't want is the server to suddenly lose power. I know that ZFS can survive that, I know that, But I don't want to jinx it. I bought a UPS that can keep up the server for, I believe, like 7 minutes. If it's running at like full blast. So yeah, we're going to install that, try it out, and configure TrueNAS so that it triggers as soon as the power goes out, and then it shuts down like regularly instead of just. And that's what we're going to do next time. But for today, this was it. And it was one hell of an adventure, and I'm happy that I have my 264 gigs. Terabytes. Okay. Hope to see you in the next one. Bye-bye.